Hi, I'm Jeremy, and today I'm going to tell you about what engineers have to think about to design and build a car that's powered by the wind. The first thing we have to think about is how we build our car, the base of our car. This is a car that I built out of just some Connects blocks that I found down in the basement. I'm going to take the little sail off here. You can see it has wheels and a sail. And we're going to talk about the base for a minute. The base of the car has to be stiff. When you're designing a car, you can't have the base that's really compliant or flexible. You want the base to be stiff so the wheels can stay straight when the car is moving back and forth. So here, I've created a base that's made of what's called a truss. And this is a simple box frame truss. You'll see it has links or beams or members, load-carrying members on each side. And it has these cross braces that move on 45-degree angles and support the sides. Now, one thing you'll also notice about this truss is that it can support a lot of force. What's a force? A force is what happens when, for example, I press my finger on this stapler. I'm putting a force on this stapler and useful work is happening. When I press on this stapler, I put a force on it, and you see the top of it moves down, as if I was going to staple a piece of paper. So what happens when I put a force on this truss that's the base of my car? You'll see that the truss is pretty stiff. When I put a force on it in the plane of the truss, that is this plane right here, you'll see that it resists the force that I'm putting on it. It doesn't deflect all that much. So it's very stiff in its plane, which is good. That's what I want here for my car. I want the wheels to stay nice and straight when it's traveling across the ground. But one thing you'll also notice that it's not so stiff when I press on it in a different direction. So I'm going to press on it this way here, and you can see that when I press on it out of plane, I put a force on it out of plane, you can see it's pretty compliant. That is, it's not as stiff as when I press on it in the plane. Now, let's think about how we want to design the wheels of our car. Now, you want to notice, you want to have a wide base when you have a wind-powered car. So I'm going to put the sail on, and I'm going to show you some thoughts about how wide you want to make the base. So you'll see here, I have two wheels in the back, and I have one wheel in front. And I'll tell you why that's important in just a minute. But in this case, I have a pretty wide base for these two wheels in the back. And if I can put my finger on it here, like this, and then compare it to the height of my sail, which is on a little mast here, it looks like a football goal, you'll see that my base is roughly 3/4 the height of this mast. That's really important because it keeps the car stable. It keeps it from tipping when the wind blows. So the wind will blow into the sail and the car will go this way. So let's imagine if I didn't have such a wide base, what would happen then? So let's take the car apart here. I'm going to take these two links off and I'm going to pull the wheels off. And imagine if I took the wheels and put them really close together. So I'm going to take these wheels off here. I'm going to take the sail off. There we go. I'm going to put this wheel here, and I'm going to put this wheel here. And I'm going to put them back on, just like that. Now imagine if I had a very narrow base with these two wheels very close together. If that was the case, and I had my sail on here, and a strong breeze came by, what would happen is that when I blow on it, the car would tip over. Base is not that stable, as you can see. So if a wind comes from this direction, the car tips. So that's why I want to have wheels that are very wide and spread apart in the back so I can get a stable base. And again, I want that base to be about 3/4 the height of the mast that holds my sail. So I'm going to take this apart and put it back the way it originally was. Here's my wheels. And this is the way it originally was. You see this wide base, and this base is pretty resistant to tipping. And that's what I want. Now, let's think about one other consideration. When I'm an engineer designing a wind-powered car, I also want to think about friction. Friction is the resistance that happens when an object like a wheel is rolling on a surface. So in this car, if we want it to go fast, if we want it to go for a long time before it loses energy and stops, we want to have as little friction as possible. But you have to understand where friction occurs in this car. We have friction occurring in a couple different places. The first place we have it is on these axles where these wheels are rotating. So I'll show it close to the camera here. The wheel's spinning on this axle. So one thing we want to do when we're designing a car is that an engineer wants to make sure that there's as little friction as possible between this axle and the wheel that's spinning on it. So you might do things like sand down this axle, polish it so it's very, very smooth. And that'll allow the wheel to spin freely on this axle. This is a very simple axle, but in the cars that you ride around in today, we have things called bearings, and those help keep a wheel stable and spinning with as little friction as possible. Now the second thing you want to think about with friction is rolling friction. That's the friction between this wheel and the desk that I'm rolling on here. And you want to think about the surface that the vehicle is rolling on. Here we have a desktop, and it's a nice hard smooth surface. So what happens is when I blow on the sail, my car goes. It goes really well because there's very little rolling friction between the wheels and the surface. But now imagine if I had a very rough surface. I'm going to bring in this sweater here. I'm going to put my car on this surface. So now these wheels are moving on kind of a lumpy wool cotton surface, and when I blow on it, it's a lot harder for my car to move forward because there's a lot more rolling friction here between the wheels and the surface of the sweater. So I want to minimize the friction, the rolling friction that is, between the wheels and the surface that the car is moving on. That's the first step. I'll be back in the next video and we'll talk about how to design the sail. See you then.